Hello, this is Sumati, lecturer, Electronics and Communication Department, SJ Government Polytechnic. So this is my first session, and I will be covering the Unit 2, Basic PLC Programming. In this session, what I'll be covering is about the PLC programming standards which are used worldwide. So here I'll be talking about the five standards: the structure text, instruction list, functional block diagrams, sequential function chart, and at last the ladder diagram. Out of these five programming standards, the ladder diagram is more widely used. So, the later chapters or your entire course, the programmable logic controllers, is based on the ladder diagrams. So, uh, for programming the PLCs, some standards have been developed, and those standards are developed by IEC, International Electrotechnical Communication. It is a international standard body which gives the ground rules or the standards in the field related to electrotechnology. And essentially the programmable logic controllers, they come under the electrotechnology field. So for PLCs, the standards are defined by IEC standard body, and IEC organization has developed a standard 61131, and this relates to the PLC standards. Again, in this 61131, we have a section called 3. The section 3, it is specifically for PLC programming languages. And the PLC programming language refers to set of methods and semantics which allows the user to communicate information to the PLCs. So a programming language or PLC programming language is the one which allow the user to communicate some information to the PLCs. And this IEC body has defined five standard languages that can be used when doing PLC programming. So these five languages are divided into two categories. So as shown in the screen, we have the first category is called as the textual language based languages, and the second one is the graphical language based languages. Under textual languages, we have instruction list and structured text. Here we use the text in order to program the PLCs, whereas in the second category, we have the ladder diagrams, functional block diagrams, and sequential function chart. Here we use either the flow chart or a ladder diagram or block diagrams. So all these three come under the graphical based languages, whereas the instruction list, structured text, they come under textual based languages. And coming to the first standard, that is the structured text. So it is a textual based language, and here we use high level languages like the C and Pascal can be used to program a PLCs. And this structured text, it is very powerful tool because we can execute the complex task using algorithms and mathematical functions. Here we use the statements which are similar to what we use in C language. So here you can see here as an example, I have taken buzzer equal to this is a statement which you can use a structured text language. So this statement, we use the statements like this, and the statements are separated or ended with a semicolon. And In this structured text language, we can give the priority for the input variables. Here you can see I have put a parenthesis here. A parenthesis indicates that that has got a highest priority. So in the above statement, you can see here not push C. So C variable is given a highest priority, that is computed first, and then that will be ANDed with the B input. After that, then it will be ORed with the A input. So here C has got a highest input, C has got the highest priority. So you can set the priority for the variables in the structured text language. The second standard that is used in PLC programming is called the instruction list, and this is more complicated because we are using here low level language. A low level language means a language which machine can understand. So it will be in terms of zeros and ones. The instruction list consists of some assembly language instructions. So we are using the mnemonics here. To give the instruction to the PLC, we use what are called as mnemonics. The same mnemonics you are familiar when programming a microprocessor. So here you see here, it is LDA and B, STQ. Like that, some mnemonics will be used to program a PLCs. So this is the set of mnemonics I have shown here, and for this set of mnemonics, it will be converted into a ladder diagram, and that is shown here. So those set of instructions which I showed would be converted into a equivalent ladder diagram as shown in the slide here. Now, coming to this instruction list advantages, this instruction list, it is suitable for applications that need very compact codes, and also some applications are time critical. In such cases, in those applications, I can use the instruction list. The disadvantages will include it is difficult to solve the error here because we are doing programming in terms of mnemonics. So it is very difficult to solve or debug the error. And for structuring the programming, here only few statements are available which does the function of a structuring. So like go to command can be used here. Very few commands which help in structuring of the program are available. So these are the difficulties or disadvantages you see in instruction list programming. And going back to this structured text, here the advantages are it's very organized because it's a text-based language, so and it uses the functions such as for, while, if, else, case. All those functions which are available in C are also used in structured text. So the programming, it looks very organized, and also it is good at computing the large mathematical calculations. And the second advantage is that it has some instructions which are not available in other languages. The third thing, the programming language will be the functional blocks. So again, this functional block, it's a graphical based language. It uses or it describes a function between inputs and outputs which are connected to the blocks. The functional block diagram, it was developed to create the system which uses the common repeatable tasks like counter, timers, and PID loops. So whenever a application requires that some tasks or activities have to be repeated, in that case, I can go for this functional block diagram. And here you can see here, this is a pump and pressure or test. So like this, functional blocks will be defined. Here, um, the pump and pressure inputs will be ANDed together. That is, logical AND operation is generated to produce the output at the first block, and this output will be ORed with the third input called test to produce the final output at the second block. So the functional block diagram here, the advantages include it is suitable for motion control applications. And the second advantage is that many programming lines can be put in one or several functional blocks. So in that way, it becomes more structured. So the disadvantages would include, since the function blocks are anywhere on the sheet, it becomes very difficult to troubleshoot in case of functional block diagrams. The fourth standard which we use for PLC programming is called as sequential function charts, and this resembles the flowchart method of programming. Here the steps and functions will be used. Steps and transitions are used here. Transitions are the instructions used to move from one step to the another step. The step contains the input actions which are to be programmed. Here the actions depends upon the decision. And for making a decision, I can use timing method, or I can take the decision based on the physical state of an equipment. So in this functional chart method, we will be using steps and transitions. So transitions are those instructions which are used to move from one step to another step, and the step is the one which contains the actions, and these actions will be programmed by the user. And in order to take the action, some decisions have to be done in the step box. So here the decision, you can make a decision based on the timing, or you can make a decision depending upon the physical state of an equipment. The advantages would include the process is entire process, or a control process is broken into number of steps. Hence, the troubleshooting becomes very easy and fast. Here, the designing and writing the logic for the step becomes faster. The disadvantage is that it's not suitable for every applications. And the last programming standard will be dealing is about the ladder diagram. So this ladder diagram, the ladder diagram is modeled from the relay logic, which uses the physical devices like switches and then mechanical relays. And again, this is done to control the processes. So basically, this ladder diagram is derived from relay logic. So it uses the relay logic, and in the relay logic, we would use the switches and mechanical relays as the input and output. So by using this relay logic, we are going to control a process. And in the ladder diagram, we will be using the fundamental parts like the rungs and rails. The rungs correspond to the power rails. The rails correspond, the rungs and rails are the fundamental parts which are used in ladder diagram language, the rail corresponds to the power rails. There are two power rails. Here you can see I have shown a ladder diagram in the slide here. We have two vertical lines which are called as the power rails, and we have horizontal lines. Those things are called as rungs. So these rungs contain the switches, mechanical relays, and then the output elements. Whereas the rails, they carry the power. And for this output device to be activated, it is necessary that there is a physical connection between the two power lines, and that connection is established based on the status of the input contact or input switches. Here the necessary input conditions which will affect the output are programmed using the contacts like this. The advantages include it's more organized because we are using the rungs here. Rungs means horizontal lines are used here. So this way of programming is more organized, and it's easy to follow also. The second advantage is that the comments are readily visible here, and the third thing and the most important advantage is that online editing is also possible here. So these are the three advantages of a ladder diagram. Coming to the disadvantages, this programming of motion control and batching, this is more difficult in case of ladder diagram. So if I use a ladder diagram to program a application wherein I need to control the motion, and then I need to have a monitor the batching, all those things, such type of applications, it becomes very difficult if I use a ladder diagram in such applications. So let us have a recap of what we went through in the from the beginning. I said about in this session we talked about the IEC standards 61131. In this standard, the section 3 is specifically for PLC programming language, and this IEC 61131 is the standard body which gives the ground rules that has to be followed worldwide. So the section 3 covers the standards about or rules for PLC programming languages, and again this IEC divided or it has categorized the 5 languages into two types. We have textual based language and graphical based language. In textual based language, we went through instruction list and structured text. Again, in graphical based language, we had the ladder diagrams, functional block diagrams, and the sequential function charts. In textual languages, we were using text to program a PLC, whereas in graphical languages we used the flow charts, ladder diagrams, logic diagrams, and then the block diagrams. The structured text ST, as it is short hand notation. This structured text is text-based language, and it resembles your high-level language. So we use the C and Pascal language here to program a PLC here. And here the functions like for, while, else, if, all those functions can also be used here for doing the PLC programming. And here we use the statements, and all those statements they end with a semicolon. So the structured text language, it uses the statements which are terminated with the semicolon, and it also uses the functions which we use in C language. So the advantages becomes it's more organized and can be used to do the large or It is good at computing a large mathematical calculations, and this system has got some instructions which are not available in other languages. The disadvantage is that the syntax is very difficult, and debugging is also very difficult, and here online editing is not possible. And the second one we went through was the instruction list. Again, this is also a text-based language, and it resembles the assembly language which we use for microprocessor programming. Here, the mnemonics will be used. The example I've shown here, this set of mnemonics, if it's converted into a ladder diagram, will look like this. Then we went through the functional block diagram way of programming, and this is a text-based language, and here the blocks are available in the programming software, and this FBD method is useful in applications where some tasks are carried out repetitively. So in such cases, we can use the functional block diagram way of programming, because some common and repeatable tasks are just added. This may the tasks like counter, timer, PID loops, all these things are most of the time in a program. Number of times they will be repeated. So in such cases, wherever the repeatable tasks are used in the applications, there we can use the functional block diagram. And the advantages is that it is suitable for motion control applications, and here many programming lines can be put into one or several functional blocks. The disadvantage of this language is that the blocks are arranged somewhere, anywhere on the sheet, so it becomes very difficult for troubleshooting. The last but one is your sequential function charts. Again, this is a text-based language, and it uses the flow charts here. And again, it consists of steps and transitions. Transitions are nothing but the instructions which I use to move from one step to another step. Whenever I want to move from one step to another step, I need to satisfy some conditions, or some decisions have to be made. So those decisions are can be based on timing, or it could be based on the physical status of the input devices. So here the advantage is that entire control process is broken into number of steps, hence the troubleshooting is fast and easy. Designing and writing the logic inside the step also becomes faster. The disadvantage is that it is not suitable for every applications. The last the language or a standard we went through was the ladder diagram, and again this ladder diagram is text-based language, and here we use two fundamental parts like the rails and rungs. The vertical lines which carry the power are called as the power rails, and the horizontal lines where we put the contacts and the coils are called as the rungs, because it's arranged in the form of a rung. So the advantage is that this ladder diagram is more organized, and hence it's easy to follow. Here the comments are readily visible, and also the most important the most important advantage about the ladder diagram is that you can do the online editing. That's when the process is going on, still you can at the same time at the same time you can edit your ladder diagram. So this is the most important advantage of ladder diagram. The disadvantage is that the programming of applications wherein controlling the motion and batching is involved. that type of applications programming is a bit difficult if I use a ladder diagram. So these are the five programming standards defined by the IEC organization. Now let's have a look at the quiz part. So here you can see, I'll read out the question. Name three graphical languages which are used for PLC programming. The options are ladder diagram, functional block diagram, instruction list, sequential function chart. The choices are ABC, BCD, ACD, ABD. So try to answer this question. The answer is ladder diagram, functional block diagram, sequential function chart. That is the choice C, A, C, D. The choice A, C, D. So uh, the ladder diagram, functional block diagram, sequential function chart. So all these three belongs to graphical based languages. The second question is high level language like C, Pascal is used in which standard? The choices are instruction list, functional block diagram, structured text, none of the above. So the answer for this question is structured text. So in case of structured text programming, we use high level languages like C and Pascal. The third question is about assembly language is used in which standard? So assembly language means the mnemonics. So mnemonics are used in which standard? The answer is it is the instruction list. So in case of instruction list language, we use the assembly language. So instruction list programming resembles the microprocessor programming. The next question is which standard is suitable for motion control applications? The options are instruction list, ladder diagram, functional block diagram, sequential function chart. So the answer is functional block diagram, choice C. So whenever the application requires that I need to control the motion, in that case, your functional block diagram language could be used. The next question would be which standard is based on flowchart? The choices are the ladder diagram, sequential function chart, instruction list, structured text. The answer is sequential function chart. So sequential function chart basically uses the flowchart method. So the two fundamental parts which you will use in a flowcharts are the steps and transitions. So the choice is B, sequential function chart. Next question would be which standard is based on relay logic? The choices are ladder diagram, instruction list, structured text, functional block diagram. The answer for this is ladder diagram, that is choice A. So your ladder diagram was modeled based on the relay logic. Thank you.